see how can we do this derivation of non-inverting amplifier. As it said non-inverting, so non-inverting means it voltage is connected with the positive terminal, right? And there is no change in the phase, means if I'll give the input voltage in the this phase, then I'll get the output voltage in the same phase because it's a non-inverting. Okay, so input is connected with the positive terminal. Let us mark there is some amount of current flowing in the feedback resistance, that is I2, and there is some amount of current flowing in the R1, that is I1. Okay, here the voltage is V1, here the voltage is V0. So can I say that the non due to the non-inverting amplifier, due to the virtual ground concept, here at this potential the potential is V2. According to the virtual ground concept, here the potential is V1, and V1 must be equal to V2 with the concept of virtual ground that I told you in the last class, right? So you can directly write down that at this potential and this potential would be equal because of virtual ground. Got it? So here is the I2 current flowing and I1 current is flowing. If I'll apply Kirchhoff current law, can I say that I1 is equal to I2? Hmm? I1 is moving from, like at this point the voltage is V2, then in that case this point also the voltage would be V2, as there is no no element is connected between these wire, right? So I1 is moving from V2 to 0 or 0 to V2? Tell me. Yeah, so it would be V2 minus 0 divided by R1, right? Similarly, tell me about I2. I2 is moving from V0 to V2 or V2 from V2 to V0? Just see the direction carefully. It is moving from V0 to V2. So what can I write down? No, V0 minus V2 divided by R, because there is no 0 over there. There is a some potential V2. Okay, so for this we'll get the value. Now what we want to calculate, as I told you, we always want to calculate voltage gain, and voltage gain is how much? Output voltage divided by the input voltage. Here voltage, input voltage we have provided V1, so V0 by V1 we need to calculate, right? So V1 is equal to V2, right? According to the concept of virtual ground. So can I write down like V2 by R1, or we can say V1 is equal to V2. So V1 by R1 is equal to V0 minus V1 by RF. Can I write down like this? Hmm? So now we need to calculate V output voltage divided by the input voltage. Input voltage is how much? Tell me. Input voltage is V1, right? Because we are providing voltage to the inverting, non-inverting input. So at this point of time, we need to calculate V0 by V1. Now tell me, how can we get V0 by V1? Can I write it down like this? V1 by R1 is equal to V0 by RF minus V1 by RF. Hmm? Similarly, I can shift this V1 to the another side. So it would be V1 by R1 plus V1 by RF is equal to V0 by RF, right? So if I can take V1 as a common. So if I'll take V1 as a common, then what would be the answer? V1 divided by, that is 1 plus R1 by RF, 1 plus R1, 1 by R1 plus 1 by RF is equal to V0 by RF, right? So I can take the LCM R1 RF, that is RF plus R1, right? V1 RF also I'm shifting to this side, RF is equal to V0. Now we got the value for V0. As you can see, this RF and this RF can be cancelled out. So what is the final answer? That is V1 RF plus R1 divided by R1 is equal to V0. Now can I write down V1 RF by, can I write on RF by R1 plus R1 by R1? So if I'll do it finally, solve it completely, then what I'll get as a final answer, then I'll get as V naught is equal to V1 1 plus RF by R1, right? So this is our final output voltage for which case? For the non-inverting amplifier. As you can see, we don't get any negative sign. If there is no negative sign, means there is no change in the phase. Phase will be same. Okay. So it would be RF by R1, R1 by R1 is equal to V naught. So R1 by R1 is 1. So what we got as a final V1 1 plus RF by R1 is equal to V naught. This expression you need to remember it for the numerical purpose.